Hello everybody, welcome to Marketing Analytics course. This is Dr. Contd Chatterjee from VGSOM IIT Kharagpur who is taking this course, and we are in week 11. And we are still discussing text mining and sentiment analysis, and we will continue the same thing in this particular week also. Till the last week we have done basic sentiment mining, basic text mining, and we have also done some bit of spam detection and etc. using knife Bayes algorithm. Here we will actually use that in sentiment mining. So, we will use knife Bayes for sentiment mining in this session. In the next sessions, we will use certain libraries which has been pre-developed by some researchers for various kinds of application in various places, and later point of time we will do a little bit of topic modeling also. So, in this particular class we will be using the data set called hotel_review. So, this is the same old data set which have been used earlier by us, but here I have only included the text part. So, if you see this data set carefully, that this data set has 4 columns, which is the hotel name, the review title, the overall rating that you have got, and the review content, the basic text of the review, and these are all content like this place is very nice to stay, close to the railway station. The owners are the best and will help you with all your questions. We would definitely recommend this place, blah blah blah, all of these things. So, each of these things is one review. So, the quantitative version of this particular thing, the data set, we have used in week 1. If you remember, there was in the week 1 we started with a discussion that if the overall rating is there, and if you also get, let us say, the service, location, service, sleep quality, you get the ratings of all those stuff, then how various service attributes are impacting your ultimate overall satisfaction or overall rating that you have given is sometimes we find out through regression. We also try to find out that which of the aspects are more important in your service context, which aspects are not important, where you are doing good, where you are doing bad, and blah blah blah. The same data set we have been using here, but with the text part. So, I want to know that what kind of extra insights we can bring in using the text also. Means till now we are only using quantitative data. Now, I am bringing in qualitative data in this particular model building to find out that how we can get enough information from the qualitative data also to make certain sense out of it. So, in this particular class we will do that. So, we will be using as usual R programming and the knife Bayes algorithm to do that. So, if you remember a small recap of the knife Bayes algorithm, it says that probability of A given B is probability of A and B by probability of B, which is also probability of B given A into probability of A by probability of B. This is something that we will be using. For example, probability of positive sentiment, let us say positive sentiment given a word called good. Let us say if that is so, probability of this given G, let us say I write it in this way, this will be G given plus into probability of plus divided by probability of G. Now, in our old data set, if I have a data set and if I break it into training and testing, then in the training data, from the training data I can have an idea that in the training data I can have an idea that how many I would say reviews are there which are positive, and I can also get an idea that how many reviews are there which has this word, has the word called good. So, this will be basically probability of plus and probability of G. And then we have to find out by doing another calculation. What is this? If I can find out these things, then I can calculate probability of positive given G. So, these three simple data mining will be done by naive Bayes algorithm. So, the first thing is that, so these are P actually, I have written it in a different way, this should be P. Okay. So, that is something that we will be doing here. So, if you check this particular centi.r, this is the R file. So, we are using the same old formula of naive Bayes, but in this context, in this particular context, which is our review data set, we will be using this thing. So, the first job is to read the data. So, session set working directory to source file location, and then after setting the working directory, you read the data. And the data has 942 observations of 4 variables. So, how the data looks like? The data has the hotel name, the data has the review title, data has the review text, and the data also has overall rating. So, these are the 4 things that our data set has, and we will try to see that how this overall rating is related to these two stuff, the review title and the review text. Now, if I come to this thing, first thing that is want to do is structure of the data. So, the structure of the data says that my data set has basically, if you carefully look at the structure, then my data set has 942 observations of 4 variables. There are 4 variables and there are 942 observations, means 942 rows and 4 columns are there, and the column names are hotel name city, which is a factor variable with 23 levels. That means there are 23 different hotels data has been captured in this particular data set, and the review title has, review title is a factor of 923 levels. So, basically there are 942 different kinds of review titles are there. It is coming 923 because some review titles are probably same. Let us say good stay has come more than once. So, if that is the case, then we cannot say that they are different review title. There can be some common review title. For example, very good hotel, let us say that was the review title. So, we cannot do anything with that. Then comes the review overall rating. Review overall rating is the quantitative rating in a 1 to 5 point scale that somebody has given. 1 means in this overall rating, 1 means basically very bad, and 5 means very good, and anything in between that, let us say 2, 3, 4, these are mediocre. So, depending on how much is the cutoff, we will decide whether it is a positive review or negative review. And then comes review content, which is the text, and there are 941 levels because probably one thing, there is exactly 2 reviews which are similar to each other, otherwise they are dissimilar to each other. So, we got basically these 942 observations. Now, I just press Ctrl L to clean my console. Ctrl L is to clean my console, and once I clean the console, next what will I do? So, what I do right now is I break the data set, the currently given data set, into 2 halves. One is the positive reviews and another is the negative reviews. So, how to find out positive review? We call it something called median split. What is median split? Find out a median of a variable and then split it. For example, let us say if I just find out median of data dollar review overall rating. So, that is coming up to be 4. So, frankly speaking, any review rating which is, and if I just put a histogram of the same thing, this is how it looks like, the histogram. So, which one will I say positive review and which one will I say negative review? So, can I say that all these 5s are positive, these 4s probably are also positive. So, majorly biased towards positive review, but 3, 2, 1 are obviously negative reviews, these guys are all negative reviews. So, I can say that. So, if 3, 2, 1 are negative reviews, 4 and 5 are positive reviews. So, what I do here is data dollar review overall rating is, let us say if they are greater than, or let us say greater than equal to, if I just write greater than, that means it should has to be higher than 4. If it is not higher than 4, then it will be negative. So, data review overall rating is if else data dollar review overall rating greater than the median of that, then it is 1, otherwise 0. So, change this thing to 1 0 is what I am trying to do. So, I am changing it to 1 0. So, I will later rather say greater than equal to, okay. Because if I just write greater than, that means only 5 will be considered as positive review, 1, 2, 3, 4 will be considered as negative review, which is not the case probably. So, greater than equal to I will say, up to 4 it is 4 and 5 it is positive review, and otherwise it is negative review. So, I changing it to 1 0. So, now if I just try to see table data dollar review overall rating, I have 210 zeros and 732 ones. So, this is my situation right now. So, next what will I do? I will make them factor this 1 0, instead of considering as 0 and 1 2 numbers, we should consider them as 2 groups, 2 factors. So, I am changing it to 2 factors. Now, if I want to see the table of this thing, the same thing whatever I told will be there. So, 210 to get an idea, 210 divided by 942, that comes up to be 22% are negative and around 78% are positive. But still this is biased, but this is not heavily biased. So, that we have to use something else, it is not like that, it is biased, but we can still use this one. So, we will be going ahead. Now, the library that I call is this TM library, text mining library. So, I will call this library, there is no package. So, we will what we will do is we will install this thing, install TM. It will take some time. Okay, it has installed now. So, now I will call this library called TM. So, I call this library, it is saying that TM has been built under 3.6.3, but it is okay as long as the warning message and as long as the other functionalities are there, we can go ahead. So, then as usual we are changing this data dollar review content, which looks like this. So, we are dealing with the review content. Why we are dealing with review content, somebody else will tell you. Sometime later I will tell you that review content is something where the text is of significant size. On the other hand, review, I should not have actually clicked review content the whole thing, because there are lots of content and it will get printed here. Yeah, so it got printed. So, these are the, so this is something which is of huge text size. You will see that this is one content, the ambience and the climate over there tells it all, the energy blah blah blah. So, all of this, the whole content is of a significant size. On the other hand, if I just printed review title, review titles were small. So, there are not enough words to analyze the review title that whether they are impacting the overall rating, but they might be impacting more than other things. So, anyways, we will deal with review content. So, this content we change it to corpus form as we did in the last video. So, once we have changed it to corpus form, we print the corpus, and the corpus has basically a metadata which has 942 documents, and if I want to inspect the first 10 documents, these are the first 10 documents. So, 1, 2, so these are all text that is there. Now, you see in this text there are lots of punctuation marks are there, lots of numbers are there, lots of various other things are there. So, these things may not have any meaning. So, the first job as we read any data set is to probably do a little bit of pre-processing of the data. So, this is very important, more so in the text context, that you have to pre-process your data. So, what do I do to pre-process? I first content transform to lower, that means I change the whole data set to the lower case. So, this is equal to sign, this is basically equal to sign. We have discussed in the first class that this is also how equal to signs are written. So, I run that, and in corpus clean the everything that is there in corpus clean is basically in the lower form. So, if I just write corpus clean, you see that here this I has been changed to its lower case, or let us say visited in end April, very. So, everything after full stop has become lower case. So, the whole data set is right now in lower case. Then I remove the numbers. I have removed the numbers. Then I remove the stop words. So, what are the stop words? Stop words are generic words which do not have any contribution in the meaning of the data set. So, we remove the stop words, we remove punctuation, we remove white space. So, one by one I am removing, lots of warning messages are coming up. Right now we will not bother, later we will see. And then what I do is with this data set I create a document term matrix. So, in my document term matrix it is also a large document, and and basically it is document term matrix looks like this, that there are lots of words, word 1, 2, and there are 942 columns. And this is basically a matrix where the counts are there, all the counts, how many times one particular word is occurring in which particular review, that is there. Now, obviously, I have to break it in training and testing. So, if you remember in the last class, we have done training testing by taking the first 70% or 80% as training and the last 20% as testing. That we cannot do here because there are ways people. So, your past reviews actually sometimes impact your future reviews. So, how the person who has reviewed the last review that I see, when I go and write my review, I also see the last review, and if I see that review is positive, sometimes my mind also gets diverted towards positivity or negativity. So, all I am trying to say is that other people's review might impact you. So, that is why we cannot take the top 400 as testing and lower 200 as training or something like that. We have to do it randomly. So, for that I am using a sample function. So, sample function samples 660 observations from 1 to 942 in this column. I create a vector called 1 to 942, out of that 660 observations will be randomly picked up, and replacement is equal to false, means once it is picked up, it will never be picked up again. It is not a sampling with replacing, it is sampling without replacing, means if 66 has been selected once, 66 this particular number cannot be selected once more. So, that kind of a sampling we are doing and putting it in A. So, my A is right now some random numbers that got generated from 1 to 942 and the length is 660. Now, with this row names I am creating the training data, and minus A means the rest of the row names goes to the testing data. So, data $10. Similarly, if you remember in the last class also we created training testing for the DTM and training testing for the clean corpus, because we will create I would say certain kind of word clouds using the corpus, and to see that whether word is the way to find out whether that it is a positive review or negative review, and then we will be doing our naive base using the document term matrix. So, next what I do is, as I told that there are, if you remember, 22.2% positive, negative, this was there 22.2% negative. So, if I just see currently what is the case, you will see that 23.1% are negative in your training data and your testing data 20.2%. So, not very different, it is little bit different, not very different. So, I can probably sample once more and then I can do it to check that whether the prof table has improved a little bit or not. So, let me just try out that. So, 21 and 23, it is okay, I think that is fine. So, to have a replaceable or something which is obvious, which will whatever I get and you get will be same, you write set seed, set dot seed is let us say some number, any number 10. So, now my results and your results will come same. So, now set seed and then this once more and then the training data, testing data once more, then the prop tables and etc. So, document term matrix and proportion table. So, 22.77 very good and here also 21 and 0.79. So, we will go ahead with this. Now, what I do is I call a library called wordcloud. So, let us see. Okay. So, this package is now there. So, install dot packages wordcloud. So, let us install this one. So, it got installed. Now, with this package I run this thing. Oh, okay, I have to call the package first and with this package I run this thing. So, the most common word is basically rooms, fair enough, and then valley, friendly, helpful, some night, some other words are also there which is coming up. Now, rooms has to be the most common word. So, I should have probably removed that as my stop word, but it is okay. Now, if I do the same thing for the training data without this randomness, then hotel, room etc. comes in the middle. So, hotel, room, good, food, room and rooms are same. So, I should have done something called stemming to remove this room and rooms thing and then the rest. Now, I break the data set based on high and low. So, this is high rating where the overall rating is 1 and the low rating of training data where the overall rating is 0. So, I am breaking the training data set into further two halves, high and low. Then I am creating a word cloud for high and I will create a word cloud for low and I will compare that whether they are coming similar or not. So, let us create a word cloud for high. So, high in this case hotel is common, but good, room, great, these are the words that are coming up. Just check, remember this. So, good, food, staff, stay, service, great, these are the words that are coming up. Now, if I just try out the same thing with a different, I will just clean this and then I will run with a different which is low, then what comes up? So, hotel room, rooms are common in both the cases, but see this good, great has gone away, fair enough. Staff, food, room, rooms, hotel, these are all, but great is there in a much smaller size and practically good is not there if you see carefully. So, then these adjectives, not the nouns, but probably the adjectives are something which can contribute towards your positiveness or negative, and that makes sense that when we do a review of anything, if you say that okay, I am a good teacher, teacher is a noun, good is an adjective. So, by this good or bad or lazy or very energetic, these are the words that we use to define how this teacher is. So, teacher is not creating any kind of positive or negative sentiment, emotion, it is not creating, these adjectives are creating. So, that can be one learning from basic exploratory analysis of putting a word cloud. Now, what I will do? I will find out the frequent terms up to 5 frequent terms. So, there are 1607 entries which has occurred at least 5 times. Make a dictionary with these words, I am making a dictionary with these words, and then what I will do is I will create a document term matrix only with this word for the training data also and for the testing data also. So, 2 document term matrix once more for the training data and for the testing data, but only with these 1607 words. Now, remember document of matrix gives you counts. I need 1 0 in the last week we have done that. So, I convert it to basically counts rather than from counts to 1 0. Yes, no, I am converting it to that. So, it has done that. Now, if I just check what is data DTM underscore test, if I just try to see that. Okay, so, this I will not be able to see this here. So, let us say data 10 1 to 10. No, this is not how I will see. Basically, the data, this is my training data. So, these are 1 to the word characters and their corresponding, these are the terms and these are basically the corresponding values 1, 2, 3, 4, 5. So, I will now use this document term matrix training to my model building. So, the library that we will use for naive Bayes algorithm is E1071, that is not there. So, install packages E1071. Oh, sorry, I should have written the E properly. Okay. So, it is installing E1071 right now. It has installed it. Now, I will call this library. It is okay. Warning message, but we do not care. Now, data underscore classifier, the model name is naive Bayes. This is the algorithm name, where this is my x axis, which is the term matrix, and the y variable is basically the overall rating that you got 1 0 rating. So, if I now run a simple this thing, I got the classifier, and if I want to see the probabilities of the classifier, I can see for at least first two. You see bathrooms, this is 0.91, 0.95 and this is 0.8. I do not think bathrooms is something that based on which things are changing a lot. Big is not at all changing, but why do not I find out group? Let us find out group, what this group is. So, if I am not wrong, I will find out group here, good here, and good is 44. So, if I just see data dot classifier 44 instead of 1 and 2, if I just try to see the 44th one, this is the goods thing, and you can see carefully that here when good is actually occurring, yes, then it is 8% times this is a positive rating and only 4.7% case. So, there is a huge odd ratios difference, 92:8 divided by 95:4. So, I can say that good is something which leads to classification. So, we are doing it with the only the review content. You can do the same stuff, exactly same stuff with the review title. So, now I use this to predict my data. Here DTM, DM testing data, testing the document of matrix we use for the prediction purpose, and then I will call the library, again the install library, install packages. So, see, I am installing because today I am using a different system actually. If you have a once installed in your system, it will, you do not have to install again. So, library G models, and then I will do the cross tabulation. So, the cross tabulation is saying that my overall accuracy level is 213 plus 33, which is around 246 by 282. So, this many times I am overall correct 87% of time based on this, and if I try to focus on, which is basically 75.5 plus 117, this one. Now, if I try to focus on that, this is my actual, this is my predicted. Now, if I am trying to see that how out of actual ones, how many times you have correctly predicted one, which is basically 213 by 223 comes up to be 0.955. So, once positive rating I am properly identifying. Negative ratings, if I just focus on, then negative rating identification is not so good, because there are 59 observations which are negative basically, but I am currently predicting only 33 of them. so which might not be good. So, we have to try to improve this classification better using further models. So, now this is an example how we can do text mining. Now, I can use this particular text mining technique, which is this naive Bayes, to create another data matrix and can predict that whether that is a positive rating or negative rating. So, this is how basically we create a prediction, a easy prediction mechanism to predict the sentiment of a particular text. In the next session, we will discuss about various kinds of libraries that we can use for testing purpose. Thank you very much. I will see you in the next video.